Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Machines. What do machines do? Machines help us to do work. There are two types of machines: simple machines and compound machines. Compound machines are made up of two or more simple machines. The machines we're going to concentrate on in science class are called simple machines. You need to know that simple machines change the size or direction of a force in one motion. Simple machines change the size or direction of a force in one motion. It's good to know that compound machines are a system of two or more simple machines. Compound machines are a system of two or more simple machines. Please know that machines do four things. 1, they help us to do work more easily. Machines don't save work from being done, but they do help us to do work more easily. 2, a machine can make a force greater. 3, a machine can change the direction of the force. And 4th, a machine could increase the speed of the force. So 4 things. They help us to do work more easily. A machine can make the force you put in the machine greater. A machine can change the direction of the force, or a machine can increase the speed of the force. So before we move on, there are 3 important words associated with simple machines. Those words are efficiency, work, and power. Efficiency, work, and power. When we deal with machines, we always want them to be very efficient. So write this down. Efficiency is measured by the energy output compared to the energy input. So the energy output compared to the energy input is called efficiency. So what is work? Take note that in order for work to be done, 2 conditions must be met. 1, the object must move. And 2, a force must act on that object in the same direction as the object's motion. So 2 things. The object must move, and the force must act in the same direction as the object's motion. When doing work, a force must move an object a certain distance. The force and distance the object moves must be in the same direction. Therefore, if the object does not move, no work is being done. So, for example, a girl holding a textbook above a table, she's not doing any work. She may be exerting a force on the textbook, but no work is being done. If you're carrying an object, the direction of motion and the direction of the force are different, then no work is being done. Work is measured in joules. In order to calculate work, we have to have the measurement for force and for distance. So force is measured in newtons, and distance is measured in units called meters. You should know that the formula for work is work equals force times distance. Work equals force times distance. For example, if you move a desk with a force of 5 newtons and you move at a distance of 10 meters, we can solve work by saying 5 newtons, our force, multiplied by 10 meters, our distance, equals 50 joules of work. We applied a force in the same distance. It moved an object. We call that work. What is power? This is on your test. Power is the rate at which we complete work. So how much work gets done in a certain amount of time? Here's an example. Jack and Jill both have to cut their lawn. Jack completes his half-acre lawn in 1 hour. Jill completes her half-acre lawn in a half hour. So, who has more power? The answer is Jill, because Jill completed her work, same amount of work as Jack, in less time. We'll come back to that. The unit we use to measure power is the watt. In order to measure power, we need to measure work and time. Work is calculated in joules, time is calculated in units of seconds. So you need to know that the formula for power is work divided by time. Power is work divided by time, and the units for power are the watt. So let's go back and solve that lawn mowing problem. Jack cut his lawn, a ½ acre, in 1 hour. So that's 0.5 joules divided by 1 hour. His power was 0.5 watts. Jill cut her ½ acre lawn in only a ½ hour. So that'd be 0.5 joules divided by 0.5 hours. 0.5 divided by 0.5 equals 1. Her answer is 1 watt, which is greater than Jack. So Jill did more power than Jack. Both work and power are related to machines. Machines help us to do work and increase power. The more efficient a machine, the better. So now let's talk about those simple machines. Let's take a look at 6 simple machines. The first one we call the lever. The lever is a rigid support that pivots on a point. The seesaw is a wonderful example. Levers come in 3 classes that you'll learn about more in science class. Depending on what's in the middle, depends on what type of lever it is. So if the fulcrum or pivot point is in the middle, we call that a first class lever. If the resistance or load is in the middle, then it's a second class lever. And if the effort is in the middle, then the lever is a third class lever. Once again, we will do those examples in science class. Next simple machine. You also need to know about inclined planes. An inclined plane is a slanted surface that helps you to do work. Some examples of inclined planes are stairs and ramps. Inclined planes, along with other simple machines, provide us with an advantage. They help us do work. The next simple machine is the pulley, a very common simple machine. If you've ever opened blinds in your house, you've used a pulley. A pulley has 2 parts, a wheel that turns on an axle and a rope that runs over the wheel. Pulley has 2 parts, a wheel that turns on an axle and a rope. Some other examples of pulleys include clotheslines and blinds, flagpoles, zip lines, and even sailboats. When calculating the mechanical advantage of a pulley, you count the number of supporting ropes, except the effort rope if it goes down. Next is the wedge. Write this down, please. A wedge is an inclined plane that's usually used for cutting. An axe, scissors, or even a knife are common examples of wedges. The longer the wedge, the greater the mechanical advantage. Next simple machine is the screw. Please write this down. The screw is an inclined plane that is wrapped around a cylinder. The closer together the teeth, the greater the mechanical advantage. You also have to know a wheel and axle. A wheel and axle is made of 2 parts that turn together. A screwdriver is a great example. The bulb handle is connected to the long axle, and that turns the screw. Now, I mentioned mechanical advantage a handful of times with each simple machine. Mechanical advantage is very important, and we're going to learn a lot more about that in science class. But I do want you to know this. Mechanical advantage will tell you the advantage that you are gaining from a simple machine. It's called mechanical advantage. The greater the number of the mechanical advantage, the greater the advantage. Please note, we use simple machines to make things easier. We use simple machines to make things easier. Also remember that a simple machine can multiply the input force or multiply the input distance, but never both at the same time. It can multiply the input force or multiply the input distance, but never both at the same time. To sum up, simple machines make life easier. This ends our lecture on simple machines.